Hey there everybody, today we're going to be talking some more about area. Our I can statement for today is I can compute areas of composite figures. Now composite, that's when you combine more than one together. Another name for that would be compound figures. So if you look down here, there's like a square with a semicircle on top. You've put two shapes together. That's what we're talking about with a composite figure. Okay, so for our warm-up, let's talk about percentages a little bit because those are super important, as you know. If a coat is on sale for 25% off, write an expression that could represent the new price. Okay, so there are two different ways to do this. So the price of the coat, let's just call it X, right? So X, that's the original price of that coat. Now we need to subtract 25%. 25% of what, though? 25% of that original price. So in this case, 25% of X. So we're going to take the original price, that's X, and we're going to subtract 25% of that X. And it's going to look like that. So X minus 0.25X would represent the new price. There's actually another more efficient way to do this too, if you're interested. If you have a discount of 25% off, you're not having to pay that 25%. So it starts at 100%, but you can take 25% off the top. So really, what you are actually paying is the 75% that is left, right? So if you wanted to, you could just say 75% of the original price. And these two expressions, they are exactly the same, and let me show you why. Well, if there was a number, a coefficient in front of this X, what would it be? It'd be a 1. X is the same thing as 1x, right? Now we have like terms here. Can we combine those? Why? Yes, we can. What is 1 minus 0.25? You're going to actually get 0.75x. So with this expression here, when you combine the like terms, you actually wind up with that expression. Having said that, both are completely correct. You can write it either way. I just want you to know both ways. Let's look at warm-up B. Okay, if you have to pay 6.85% sales tax on a pair of shoes, write an expression for the total cost. Okay, so again, let's talk about the price of those shoes. We don't know what it is. We're going to use a variable to represent whatever that price is. Let's just say X. Okay, so now this time you have to add 6.85% to that. So we're going to have X plus, now 6.85%, we need to move that decimal, bloop bloop. We had to do that up there too, I just forgot to say it, so hopefully you knew what I was talking about. So when you move that decimal, you're going to get 0.0685. So that's your 6.85% right there, and you have to multiply that by X. So you have your original price, and then you're adding tax on that price. That's what you're doing there. Now, is there another way to write this more efficiently also? Why, yes there is. You could put that coefficient there again, and then you can combine your like terms. 1 plus 0.0685 is going to be the same thing as 1.0685 times X. So you could do this either way. Both of those would be perfectly correct. This is just a little bit shorter in the calculator. Alright, so two different ways to write the expression for total cost once you add sales tax. Let's go to the next thing. You can see I have a bunch of stuff written here. This is just asking you to draw diagrams of all the basic figures and write the formulas that we've learned. So if you want to pause your recording real quick and write something like this, and you can draw it your own way or you can draw it my way, either way works. Just make sure you have the formulas written down and a nice little picture for yourself to look at of the various shapes. So hopefully you've already paused it and copied all the shapes down. Oh, by the way, I meant to say at the top of this recording, you do not have a written worksheet for today. These notes are the only thing you have to turn in. So when you're done watching this video, you are done for today. Okay, let's keep going. A composite figure, that's what we're going to write in here. It's composite or compound. It would be the same thing. I'll even write /compound because they're both correct. So a composite or compound figure is a geometric shape made up of, that should be a D, my apologies, made up of more than one basic geometric figure. A composite figure can be broken into basic geometric shapes to make area computations easier. Okay, we're going to show you a bunch of examples in just a second. So in example 1, it says find the area around the nearest hundredth. Okay, be sure to show what basic shapes you're using. Yes, because there's more than one way to do a bunch of these. So look at this shape here. Well, it's kind of like a big square with a corner cut out of it. How could you think of this? Well, when I look at it, I kind of think of it being divided along here. So you have this, it looks almost like a square, but that length and that length is different. So I guess it's technically a rectangle. So you have this little rectangle sitting on top of a bigger rectangle. So I would write it like this. You have that plus the bigger rectangle. And if you add the areas of those two shapes together, then you're going to get the area of the whole. So let's put some dimensions on these two figures. We have the top is 3.1. And this side here, that's the same as this side here, right? That's going to be 3.4. I'm not going to write centimeters because I'm already kind of small here and I don't want to run out of room. Now, what about the length of this right here? How can we figure that out? Is it doesn't tell us here what that is, but it does tell us this length and that length. So we're going to have to add those together to get the top right there. So let's just grab our calculator. I definitely encourage you to use calculators on these problems if you want to. So 3.1 plus 3.8. And when you fit those two sides together, you get the top of this rectangle here, which it looks like it's 6.9. So I'm just going to write my 6.9 right there. And what about this length here? This one is labeled for us. That's just 3.7. Okay, so let's figure these out and add them all together. So this one here, you're going to do length times width. So 3.1 times 3.4, that's going to give us 10.54. What about this one? 6.9 times 3.7, 25.53. So if you want to find out the area of the whole, which is what we want, you got to add this and this together now. So 25.53 plus 10.54 looks like we're going to have a total of 36.07. And those are centimeters squared. So that would be your answer for that one. Now, are there different ways to look at this? Absolutely. You could think of it as a big rectangle going this way, and then the smaller rectangle here, so kind of like this. That plus this. You can figure it up that way. Does anyone see a different way to figure it up? This one's kind of fun, I think. You could think of it as a big square. I'm going to just write or here. Big square, like this, out to here. And then you would have to subtract out this missing part. So I'm going to do big square minus, and it's not a square, it's a rectangle, isn't it? Minus the little rectangle. That would also give you the correct answer. I'm not going to show you, but feel free to play with those on your own. Or, well, we're not doing an assignment today, but when you get to tomorrow's, then you can definitely try out different things if you want. Let's go on to part B. Okay, so what shapes do we have? It seems pretty clear that we have a square down here because both sides are 11.6, right? And then on top, what do we have? This would be a circle, but it's only half of a circle. So we have a semicircle, which I believe is Sandy Rank's favorite shape, right, Sandy? Okay, semicircle right there, and then a square right there. Okay, so for the square, let's go ahead and do 11.6. times 11.6. That's just the length times the width, or you could say side squared if you want to. 11.6 times 11.6 gives us 134.56. All right, so the square we know. Now let's figure out our semicircle. So what was that formula for the area of a circle again? Oh look, it's right up here. Area equals pi times r squared. So where am I going to find the radius of this semicircle? Well, the radius is going to be halfway across the whole side. Well, I was going to say the side of the square. It's going to be halfway across the circle, so it would be half of the diameter. In other words, it would just be this right here, which is going to be half of 11.6. So let's use our calculator to figure out the radius. Let's do 11.6 divided by 2. and that's going to be 5.8. And I'll just write that right here. So now we know our radius is 5.8. So the area of the whole circle, we have to remember to take half of it after we're done, okay? Because it's just a semicircle. But let's go ahead and find the whole circle first. So the area of the whole circle is going to be pi times r squared. Now r is 5.8. Pi r squared. Okay, what does that equal for the whole area? Let's do 5.8 squared. You get 33.64. And I'm just going to multiply that by pi. Now, I don't know why I do those numbers backwards. It's like an old habit for me or something. If you want to do pi times, what was the number? 5.8 squared. That's more like the order we had it written down in, right? Pi r squared. It'll give you the same thing. So 105.68. It says to round to the nearest hundredth, so we'll just keep the first 6 and the 8 there. So 105.68. Okay, so that's the area of this whole circle if we had the whole circle, but we don't. We only have half of that. So we're going to take this and divide it by 2, and let's see what we get. Answer divided by 2, 52.84. Okay, we're almost done. Now we already knew the area of the square, it was this. We just found out the area of the semicircle, and it was this. Let's add those two together to get the total area. So let's get 134.56 plus 52.84 equals 187.4. And the units, centimeters squared. And we're done with that one. Okay, so let's go on and look at part C. Now, if you want to try C by yourself, go ahead and stop the video and see what you can do, okay? Let's go ahead and solve it now. I'm going to divide this. What I'm seeing is a rectangle sitting on top of a parallelogram. Is that what you're seeing? So you can kind of think of it as this plus this. All right. So sides. 8 centimeters here, 6 centimeters for the top. So we can go ahead and tell that one's going to be 48. Did that one in our head. All right, awesome. Let's look at the parallelogram. Now, what about the height of that parallelogram? It looks like the total height here is 14, and this much of it was 8. So 14 minus 8 should give us the height down here. 14 minus 8 is 6. So I'm going to write my 6 there for the height. What about for the base? What is that? Well, we know in a parallelogram that this base is equal to this base, in other words, the top. And so do we know what this measurement is? Yeah, it's got to be equal to that. So this is equal to this, which is equal to this. So we know that we can just put another 6 right here. Okay, so for the area of a parallelogram, you have the base times the height. So it looks like our total area there would be 36. 6 times 6 equals 36. Now all we have to do is add together the 48 and the 36. And that is going to be 84. 84 centimeters squared. Okay, let's look at this next one. This one's a little bit crazy. And by crazy, I most definitely do mean fun, right? Because it's nice when these are a puzzle. Okay, so what do we have? Over here we have a triangle, right? All right, so remember that's 1/2 base times height. Let's go ahead and figure this up. So the base, I'll go ahead and write my 1/2. The base is going to be 12.1. And the height is going to be, you can just put your fingers over that to see it better if you want. It's 11.2. You're going to multiply all of that together and let's see what we get. And if you don't have a fancy fraction button on your calculator, that's okay. You can just multiply these two together and then divide the whole thing by 2. In fact, that's what I'm going to do right now. 12.1 times 11.2 equals that, and now I'm going to divide it by 2. So we're getting 67.76 for the area of that triangle. Okay, now let's figure out the other side. Now what does that look like? It looks like part of a circle, right? Is it a semicircle? No, because that would just be half a circle, right? This isn't a half a circle, this is a fourth of a circle. we've got it just going this far. And we know it's exactly a fourth of a circle. Well, for one thing, it looks like it, right? But also, this degree mark, this means it's 90 degrees. Now, a whole circle is 360 degrees, and 90 is a fourth of 360, so we know this is exactly a fourth of a circle. It's a quarter circle. Okay, so now that we've established it's a quarter of a circle, we need to figure out the area of the whole circle and then take a fourth of it. So if we had the whole circle, of course, no. Do I have room? No, and I can't even draw. I don't have room to draw the whole thing, and if I did, apparently it would look smushed anyway. But using what we've got here, what is the radius? Well, the center of the circle would be right here, and it should be more like over here. Oh man, what if I just drew on this one? There we go. Now, oh, it's still smushed. Oh, that's so bad. If y'all want to laugh at me, it's okay. If this was the circle, or maybe more like that, the center would be right here, and this line, and this line, in fact, any line going out to the edge, those would all be a radius, right? Each one of those is a radius. One of those happens to be labeled with the length, and it's this one right there. So the length of the radius is 11.2 meters. So we're going to plug that into our formula, which is pi r squared. So area of that whole circle is going to be pi times 11.2 squared. Let's see what that's going to give us. Area equals, and I'm going to use my pi button. Hey, if you don't have a pi button, no stress. You can always just do 3.14, okay? In fact, I'll just do that right now for just to show you something different. So 3.14 times 11.2 squared. Now make sure you're squaring it. Don't just multiply it by 2 because it'll give you a totally different number. So area here for the whole circle is going to be 393.88. Okay, now that's the area for the whole circle, but is it a whole circle? No, it's a fourth of a circle, 1/4. So we're going to take this and divide it by what? We're going to divide it by 4, and that's going to give us, I don't know what, some number. Let's figure it out. 98.47. Okay, so this is the area of the fourth of a circle. This is the area of the triangle. We're going to add them together, and we're going to get the area of our composite shape. So 98.47 plus 67.76, 166.23. I'm going to write it up here because I'm running out of room. 166.23 meters squared. All right, there we go. We're going to do a couple more, and by a couple I mean 3, and then we're going to save the rest of this for tomorrow. Okay, so for example 2, let's read the instructions. It says show how you would find the area, but you don't have to compute it. So just think of the most efficient approach. So let's just talk through these and not worry about actually doing the math on them. Sound good? So look at this, and what are you seeing? What 2 shapes could you divide it into where you would have all the measurements that you need and everything like that? For me, the easiest thing I'm seeing would be just to slice this off right here. So you'd have this parallelogram plus this little bitty parallelogram. The base of the big one would be 22 and the height would be 8. And then on the little bitty one, see how this height is 9? So 9 minus 8 shows us that the height of this one would be a 1. Try to write that in there. And then what about, let's see, what about this line? How long is that? Well, this one is 22 centimeters. And then subtract out the 12 to figure out what's left here. So that would just be 10 for the base on that little guy. Now I'm looking at it thinking, could you also, instead of doing it this way, could you just extend this down this way and then have 2 parallelograms that way? I think you could, as long as you had the height. Actually, no, you can't do it that way because you don't have the height for this parallelogram being on its side. Oh, but you do have the height for this way. Aha, yes, this is fun. It's like a puzzle, right? So you could also do it this way, where you have this parallelogram plus this parallelogram. And so this one you would know it's a 12 for the base because you have that there. The height is still 8. Now what about this guy over here? Your base is going to be 10, because remember this line was equal to 10. And your height is given to you, that would be 9. So either way, this way or this way should give you the same number. Let's look at the next one. See what you think. Pause the video if you want to have time to think through it without me talking. Well, you could think of it as like divided right here, so you would have some kind of squarish rectangular figure in the middle, and then these triangles on the side. Add these three together. I'm not totally sure if there's enough information for that. 5.5, I'm not convinced that we know for sure that this is equal to this, because it doesn't really tell us, but it probably would be. It's probably good enough for a mathematician, though. Is there another way that we could think of this? Well, what if we took this shape and we divided it in half this way? Then we would have two of these, and what is this? This is a trapezoid, right? And with a base down here of 8, because it says it's 8 feet wide, and then a base up here of 5.5, and then the height here would be 3. So a couple different ways of looking at that one. And what about this one? Well, you could think of it as like a square. It's probably a rectangle, actually. You could think of it as being cut off here, and then you could add that triangle here, and you could add that triangle here. Can you think of a faster way to do it, though? Maybe something that involves subtraction? I'm thinking the most efficient way would be to think of this as a whole rectangle, this whole thing, and then across the top would be a rectangle that measures 9.3 by 7.8. And then you can subtract out your triangle. Your triangle is 3, and then let's see, what's the height of that triangle? Oh, wait a second. That 3 was supposed to be this arrow here. So sorry. So the base here is the same as that, so 7.8. And then this arrow is the height of 3. I'm just going to draw an arrow here, 3 millimeters. So you could find out the area of that and then subtract out the area of that. Okay, so just fun little puzzles to think about. That's all you have to do for today. We're going to start with this carpet problem tomorrow. So yeah, if you have any questions, let me know. I'd love to hear from you, and thanks for watching. Bye!